In the problem I'm going to explain here, we're going to introduce a couple of new ideas. One idea is air navigation's bearing, okay? The bearing in air navigation. The other thing that we're going to introduce is the drift angle, okay? Both are, they're not too difficult of concepts, so let's read the problem. The heading of an executive's Learjet has a bearing of 320 degrees, okay? A bearing of 320 degrees. Now that's different than the bearing we talked about in this previous problem where the bearing was north 30 degrees west. So the bearings can be given two different ways. One way is using our directions, north, east, south, west. And another way is talking about due north. So due north. So when I have a 320 degree angle that's a bearing, so when no directions of north, south, east, or west are given, then the bearing is due north, then rotated clockwise. We actually used to teach bearings like this in geometry several years ago. I'll say several rather than many. It was really many, many years ago. Like we're talking, probably when you were toddlers. So I guess that would be many, many years ago rather than several years ago. But in any case, we used to teach that in geometry. So you go, here's our north, east, southwest, right? So you're gonna go due north. We're gonna go due north, and then we're going to turn clockwise 320 degrees. So every quarter turn is 90 degrees. So that's 90. Another 90 would be 180. Another 90 is at 270. And then we're going to turn 50 degrees until we get to 320. 270 plus 50 is 320. Now our calculator is not going to accept that as 320 degrees. So when we transfer this to our calculator, we have to tell our calculator this blue angle. Well, this blue angle is 90 degrees in quadrant 1, and then another 40 degrees right here. So our directional angle for our calculator is 130 degrees. Okay? So that's the first idea. That's the first concept. So this Learjet has a bearing of 320 degrees. A bearing of 320 degrees is the same thing as the calculator's direction of 130 degrees. The wind is 70 miles per hour with a bearing of 190 degrees. So again, they're using that word bearing, but they're not giving us direction. They're not saying north, east, south, west. So when they give us the word bearing, but with no directional north, south, east, west, we have to go due north, and then we're going to turn clockwise. So when I turn clockwise, 190 degrees, halfway around is 180, and then another 10 degrees is 190. So if that's 10 degrees, when we're going to look at our angle and standard position for our calculator, we're just shy, here's 0, 90, 180, and then we have 270, and we're just shy of 270 by 10 degrees. So our directional angle for the wind is 260 degrees. So this is our wind, and this is our, I'm going to say jet, because that's what they called it, a jet. A jet is also called a plane, but it's a very special kind of plane. Given that the airspeed of the plane is 400 miles per hour, find the drift angle, the ground speed, and the course of the airplane. Okay, so we're going to talk about the jet being in blue. So I've got the jet. And the jet was over here on the right, and the wind is over here on the left. So I'm going to put the two together right here in the middle. So the jet, 400 miles per hour into quadrant 2. So now this length represents 400 miles per hour. So this is our jet. So I'm going to call it P for plane. So that's our plane or our jet vector. And then we've got the wind. Now the wind is going into quadrant 3, very, very, very close to the y-axis. However, it's only 70 miles per hour, so it's really short. So that's our wind. Now if I take that wind and I move it over here, because location doesn't matter, you can see that what it's going to do to that plane is it's going to push the direction of that plane more towards the west. So you can see that it's going to push it, but because it only is 70 miles per hour, that magnitude is 70 miles per hour, it's not going to be strong enough to push it all the way to the x-axis. It's not going to push it all the way horizontal, but it's going to push it enough that it's going to make a difference. See, look right there. So it's going to push it enough that it's going to make a difference. So it's going to end up looking something maybe like that. Okay. This angle in between, this angle right here in between, that's the drift angle. So let me do this, let me do that. That's called the drift angle. So how far off course does it take the plane? How far off course does the wind make the plane drift off course? So that's a way to remember it. So we've got our jet plane. Now the vector of the jet plane is 400 for 400 miles per hour, and then the cosine of 130 degrees, comma, sine of 130 degrees. And the wind vector is 70 miles per hour, and our direction is 260 degrees. Okay. Now we're going to add these two together. So the plane plus the wind gives us our result, which is our ground speed, right? We can get our ground speed from the result, and we can get the course. So we'll say course direction. I like to say resulting direction, resulting ground, resulting speed. That's kind of how I think about it. So now I'm going to put this into the calculator. I'm going to take 400 times the cosine of 130 plus 70 times the cosine of 260. Make sure your calculator is in degree mode. And when you're ready to check out that horizontal, and you might as well do the vertical too, the horizontal and the vertical component, go ahead and press play. So assuming you pressed pause and you are ready for the answer, negative 269.270 for the horizontal component, and the vertical component is 237.481. So let's see. That means, now I'm going to take this picture, I'm going to resize it, and then I'll make it smaller again. So look, I'm going to make it bigger. So that means, this is a major close-up, right? Let's do orange. So that means negative 269.270, that would be left 269, right? And then 237 is up. So it's more left than it is up. So that angle that vector rather, is going to be closer to the, definitely closer to the x-axis. Just make that a little bit smaller there. And there we go. So I expect my direction, my course of the airplane, I expect the course of the airplane to be, the course is going to be, if I put this into northwest bearings, north more than 45 degrees west. So I'm going to just jot that down. North more than 45 degrees west. So let's get to it. Let's find that ground speed. So the ground speed is the square root of, remember, you're going to store this horizontal component as A, and you're going to store the vertical component as B. If you didn't already do that, you want to go back to your calculator and definitely do that. So you're pressing pause and fixing that. The ground speed is the square root of A squared plus B squared. And when we put that into our calculator, we get 359.032 miles per hour. So on the last example, the wind made the plane go faster. And on this example, the wind is pushing it in a direction where it's working against this speed, therefore it's slowing the plane down. So that's important when you're on a plane and you're looking at your arrival times. Does the plane arrive early? Does it arrive late? Sometimes weather, they say weather makes a big deal. Weather can make a difference, so that wind does play a factor. Now let's talk about the direction. So what direction is this going in? Well, I'm going to take the inverse tangent of A over B so that I can find this angle right here that is between the north and the west. So I put that into my calculator and I get 48.590 degrees, and that is more than 45. So my answer is north 48.590 degrees west. So I'm going to box that. Now, I do want to say that in the back of the book, in the answer key in the book, it might give you a bearing without the north and the west. So let's just talk about that real quick. If I've got north 48.590 degrees west, my bearing is going to be due north clockwise. So it's going to be 360 minus the 48.590 degrees, which is approximately a bearing of 311.410 degrees. So either one of those would be our answer. So either one of those would be correct. If you're more comfortable with the north 48.590 degrees west, I am too. So we can stop right there. Now the drift angle, remember the drift angle is going to be between, we talked about this, the drift angle is between the original angle and the resulting angle. So the original angle was 130 degrees, and that 130 degrees came from 40 degrees right here. So this angle right here was 130, right? I should put that in blue. 130, right? There's your 130. This pink angle, that pink angle is 90 plus the 48.590. So that's 138.590. So the drift angle is the difference. The drift angle is going to be 8.590 degrees. So that wind is going to potentially take our jet plane off course by 8.590 degrees. So it's important to put that calculation into the navigational settings so that the pilot doesn't get blamed for landing in the ocean.